In case we are given an obtuse angle triangle, and we are said to make all the altitudes of this triangle. What to do? This is A, this is B, and this is C. And if we try to draw a line segment which is perpendicular to BC, this doesn't lie inside the triangle. You can see it lies here. It doesn't lie inside the triangle because here in this triangle it doesn't make 90-degree angle. Now what to do? Just enhance this side BC like this. Now you can draw a perpendicular line from A to BC, and the line is here. This is the line. It is 90-degree angle. In case of obtuse angle, you can see altitudes can be formed in the exterior of the triangles. In all triangles, we have three altitudes. We have to increase all sides. And now if we try to draw altitude from point C to AB, it is something like this. It is down here. So the altitude of the triangle is CB. So first altitude is, if it is L, that is AL. Second altitude is C, and if it is M, so that is CM. Third altitude, you can see here, third altitude lies inside the triangle, and if the point is D, then the third altitude is BD. See, it is here. Third altitude is BD, which is perpendicular to AC. So right here BD. So in case of obtuse angled triangle, we have altitudes in the exterior of the triangles. Students, on page number 115, we have a think, discuss and try these section, where some of the questions are your classwork and some of the questions are your homework. So you have to solve this complete exercise in your copy. First question is that how many altitudes can a triangle have? So you know, in a triangle there are three altitudes we just discussed. Draw rough sketches of altitudes from A to BC for the following triangles. From A to BC you have to draw. So in first case you have to draw like this. It should be perpendicular. So you can use protractor. Okay. In second figure you have this ABC triangle, and again from A to BC you have to draw a perpendicular line. That will be the altitude. And similarly you have to do in the third triangle too. In question number 3, it is said that will an altitude always lie in the interior of a triangle? If you think that this need to be proved, draw a rough sketch to show such a case. Will an altitude always lie in the interior of a triangle? Altitude of this triangle lies outside the triangle. What does it mean? It means it is not necessary that altitude ever lies in the interior of a triangle. Sometimes it may be in the exterior of the triangle. So your answer is no. That is not necessary. Can you think of a triangle in which two altitudes of the triangles, here it is, can you think of triangle in which two altitudes of the triangle are two of its sides? I have explained this to you in the previous video it was explained that in a right angle triangle, its two sides are the altitudes for the triangle. So yes, it is possible in case of the right angle triangle. Can the altitude and median be same for a triangle? It's your work, students, and the hint is also given. Do it. And one more hint I'm going to give you. The hint is construct equilateral triangle and isosceles triangles and attempt this question. Now we have our exercise 6.1 and third question is your homework. First and second question is your classwork. So students, your first question is, in triangle PQR, the triangle is here, you can see. In triangle PQR, where D is the midpoint of QR. Here, this line segment is QR and D is the midpoint of this line segment. So the line is now divided into two equal parts. Okay. D is the midpoint. Your question is, PM line segment PM is what? Here you see line segment PM is given here. It intersects QR, means the line PM, line segment PM intersects QR at 90 degree. It means PM is an altitude. So PM is an altitude right here. PM is an altitude. Okay. Next question. It is said here PD is what? And you know that PD is, here it is, point D divides QR in two equal parts. So D is the midpoint, and when we add this D to P, which is the opposite vertex, it becomes median. It is a median. Okay. Is QM, here it is QM is equal to MR? QM is here and MR is here. That is not possible, because it is not necessary that an altitude divides the base into two equal parts. It intersects the side at 90 degree. It is not necessary that it divides the side into two equal parts. Point D divides QR in two equal parts. Question number 2. Draw rough sketches for the following. In triangle ABC, BE is a median. Students, here BE is a median, it is said. It means median goes through the vertex B. Here we have a triangle and names of the vertices are A, B, C, and it is said that BE is a median. Median goes through B. It means the median goes through the midpoint of the opposite side of vertex B, and opposite side of the vertex B is AC, and midpoint of AC is considered as here. So add B and this point and write here E. Now here BE is a median. You can draw the diagram. And where AE and EC are equal. You should know this thing. Next question is, in triangle PQR, here it is, in triangle PQR, PQ and PR are altitudes of the triangles. PQ and PR, these are the sides of the triangle, because you can see these altitudes are made of sides of the triangle. In right angle triangle, this is possible. So let's make a right angle triangle. And it is said that PQ and PR are altitudes, and point P is the common for both the altitudes. It means point P is that point where 90 degree is formed. So P is here, Q is here, and R is here. It is 90 degree. PQ and PR are altitudes for the triangle. Check it. PQ and PR. See here, this PQ and PR are altitudes for this triangle because they intersect the bases at 90 degree. Here PR is here, PQ is here. This is your second question, part B. It was part A. And here part C of the question. In triangle XYZ, YL is an altitude in the exterior of the triangle. It is clear that Y is the vertex of the triangle through which altitude goes. And this altitude lies in exterior. In case of obtuse angled triangle, it is possible. So let's make an obtuse angled triangle. And Y here in the given triangle you can see vertices are X, Y and Z. And from question it is given that YL is the altitude. So this time we have to extend this line XZ to keep the altitude in the exterior of the triangle. Now you can draw the altitude from Y to base XZ like this, and this is the right angle which is formed here. This is the point L. Now you can see for this triangle XYZ, YL is an altitude which lies in the exterior of the triangle, and this is 90 degree. So students, this is the third part of the question. Now question number 3 is your homework. Do it and complete your homework and share.